Hello friends, so today we're gonna discuss this question from LeetCode, May Read Coding Challenge, Problem 11, Floodfill. This is a very standard and very important question. Even asked in interviews. Myself, I have faced this question in my interview. And the question statement states that an image is represented by a 2D array of integers. Each integer represents a pixel value. So that you imagine that there's a image which has pixels of pixel value between these values, and now you are given a source coordinate, source and like a point coordinate, SC represented the starting pixel row and column, and you have to flood fill with the new color. So actually there's a like image, 2D image, and if you click on any pixel, then all the pixels connected to it of the same color will convert to the new color. As you do in paint, I hope you understand. If you do a circle in paint and you click the paint icon and click in anywhere in the circle, all the inside the circle the color will change. That's why that technique is called flood fill, and we are going to apply this in our question. Okay, so let's take this example. Okay, the first thing to note that if we start at this point, okay, and our new color is also 2. 1 2 3 represents, imagine, different pixel colors, and we want to convert 2 to 2, so there will be no change, so we do not do anything. But let's assume we have to change 2 to 4, the color, some different color 4, and we start at 2. So what we'll do is we first check whether what's the initial color we want to start with. It's 2, so we store that our initial color is 2, which we want to start with, and you want to convert all the 2's to 4 which are like connected to this 2. So we first convert this 2 to 4, and then we'll do a DFS on all its adjacent cells, top, right, left, down, and check whether any one of them is 2 also. So like this is 2, convert this to 4, this is 2, convert this to 4, this is 2, convert this to 4, and then do a DFS on all of them again. If we start a DFS on this, now we will go from here, 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 and back to the starting point. And that's the main trick. If you haven't converted this to 2 before moving to DFS, so we have to first convert this to 4 and then start the DFS, because if you do the replacement after the DFS, this will remain 2, and when you go from this you can go back to this again, and this will again remains as 2, so like the process will never terminate. So before starting DFS you have to convert this to 4 such that when we come back it is already changed. I hope you understand. Now if you go to here 4, do a DFS top, nothing will happen. If you go on right, yeah, this is again 2. So now convert this to 4 first, and then do a DFS here again. This is 2. Okay, convert this to 4. If you go out of bounds, just ignore that. So this will be our base case. If we go out of bound, we'll do nothing. Okay, but if we, as you can see, in all the 4 directions, there is no 2 left for this. We have converted. Though there is a 2 here, but we cannot move or change it because we cannot go here by any DFS call. So this will remain 2, though it is near this 2, and we want to convert 2 to 4, and that's how we'll convert everything to 4. I hope you understand the DFS call, and now let's do the implementation of it. The implementation is also very simple if you understand the logic. So first we'll make global variables to store the dimensions, or you can also pass them in the function DFS function which we made, but it's up to you. Image dot size and m is equal to image 0 dot size, and then the first condition will be if the image color you want to change. Also these indices are starting from 0, 0. so we don't have to do anything. So the first condition which I have told you is that if our starting point from which we want to start a DFS, that color is already the same color. So if it's 2 and we want to change everything to 2, we don't have to do anything. So if the source coordinate color is equal to the new color, just return the the image. Nothing will be changed. Else we'll do a DFS in which we'll send the image, we'll send the starting coordinate, we'll send the new color, and we'll also send the color of the starting point. Why we are sending this? Because we'll only start the DFS on any other node if its color is same as the color we want to do a start DFS change. It means such that if we are on 2 and we move here, and we will only start the DFS here only if its color is same as the one from which we start, because every cell should have the color 2. That's why we'll only change the node color from 2 to 4 and then start the DFS there. So we also require this value SR SC, that's it, and in the end we'll return image. We are sending not by reference but by address, so that's why we will change actually the original image. Now we'll write this void function DFS in which we'll take the input of a vector int SR int SC int, because the new color remains same, so you can also send this by address, and color, which is the first cell color. Okay, now just write the base case or the outer boundary condition. So if SR, the coordinate, the x coordinate, if it goes beyond like less than 0, this is the very simple way to check outer bound condition. So if it goes less than 0 or greater than n, or SC is less than 0 or SC is greater than equal to m, or we will not do the DFS if the color of the cell on which we are is not equal to the color we are searching for. So this is the color of the cell on which we are, and if it's not equal to the color, then also we don't have to do a DFS there. We return. Else, now which I have told you, we have to first change the color. We will not start a DFS before changing the color. I have told you what will happen. And now just do the DFS on all the adjacent cells. So we have to send image SR -1. So we are actually sending the top cell, new color, and color. You can also make a global variable for these to save space, but is not very much required here. So it is -1, then send +1. Minus this, plus this, and then just return out of this. That's it. Let's run this first. Check. Give me the right answer. Let's submit this. So it's accepted. I hope you understand the logic and explanation. If you like this explanation, please hit the like button and subscribe button. I'll put videos daily. Thank you for watching this video. Keep coding and I'll see you in the next one. Bye.